Assalamu alaikum warahmatullahi ta'ala wabarakatuh, ladies and gentlemen. Welcome back to another stream. Alright, let me share the stream and please join my Discord server so you can actually participate in my stream. You could even talk and say whatever you want. Well, of course, in bounds, but yeah. So let me share the stream with my server real quick. Let's see. Okay. Right. Okay, let's see. Right. All right. Oh, I see the cord. Okay. Let's go. Right, that should do the job. Great. Yep, seems good to me. The stream seems fine. Microphone seems up. Camera seems good. Okay, I guess let's get started. So, last time we got this. Two color triangles that is animating depending on the time. This is just the Vulkan calls that it's doing. It's interesting though to analyze the Vulkan calls that WGPU does. It's pretty efficient, seems like, but yeah. Okay, so let's see. Yeah, I need wiki config so I could actually control that. So where's wiki config? There you go. Okay. Alright, so yeah, just gonna keep it as validation for now, I think. Oh yeah, there you go. Okay, great. So yeah, let's go. Alright. Today, I'm honestly not sure where we're gonna even start. But we probably gonna go with... Okay, so here's something that I have learned from Discord, from some dude in Discord in the graphics server, which is pretty cool. I wish I have known this earlier, but in C++ you could actually do something like this. Hold on, not here, let's say maybe here. Okay. Right, there you go. Okay, so there should be no discard. Okay. And const expr, although I honestly like auto first, but yeah. As const ptr, you get the value by reference, by const reference. I like to do it like this, honestly. No except const t. Well, I like to say t const. Because I think that's how the compiler reads it, so I like it that way. So static cast tconst, oopsies, and std address of const cast t reference. Great. So this address of is basically this guy right here. But it actually doesn't care about the overloaded operator. So let's say you have a class and you got the address of, it could call some function, but if you use like the overloaded address of function, but if you use this address of, it would ignore that and just take the memory address of that thing, which is interesting. Though you could probably go and do something like this, I think. Yeah, could probably go ahead and do something like this, but yeah, it's fine. Let's just leave it like this. Why not? Okay, great. So And with this function, what you could do, you remember when I was actually complaining about the fact that I have to create structs like this and crazy stuff like that? I don't have to do this anymore with this function. Like this is already possible in C, but it's not possible in C++. But using this function, we could do something like this as const ptr, and we just gotta take this guy and we gotta say this basically, and then we could give it whichever we want. So it's basically in the function itself. So what's up with this? Oh yeah, there you go. And yeah, that's pretty much it, I think. Yeah, I missed the semicolon there, and we no longer need this crazy scope here. There you go, and that's how you do it. That's pretty cool. I very much prefer it like this because like all the data, all the parameters of the function are in the function call itself, instead of having to go from one place to another and find out which struct is which for, etc, etc. Everything is inline. Though I'm not gonna waste too much time honestly on refactoring this. It's gonna take some time, so instead I'm just gonna use it for my new work essentially. So today we gotta deal with 3D data. Now we have some options. There's a lot of formats right there. We could go with a manual option like this, but I don't think it's too interesting. So we can use OBJ format, or we could use, for example, glTF format. I would really love to go with glTF format, but I'm not sure how hard that would be, honestly. So yeah, that's something, but I guess maybe worth a try. But let's see. But that would be very cool if we figure it out. So let's see, C++ glTF library. So excuse me, I'm gonna try something wild right now, and we're gonna see if it works. If it doesn't work, we could just go with OBJ or something like that. Okay, so we have Nugget Gallery. Nugget Gallery. Now, welcome to libglTF. Great. So there's this tiny glTF, seems like. Oopsies. GitHub. Okay. Though I remember there was some very fast glTF implementation in the graphics server, I think, if I remember. I guess. Let's see this one. So there's this library called tinyglTF. Interestingly, though I guess I've seen some other library in Discord where it's much faster. Let me see if I can find it though. That would be interesting. It's in the graphics programming server. Let me see, showcase or what it was. It was in, I guess, community projects, maybe. Yeah, I think so. It was called, I guess, fast. What about XML? Sorry, not XML, glTF. Let's see. Yeah, fast glTF, I guess. Is this the one? Let's see. Yeah, this is the one, right? Interesting. So I've seen this too. Though I'm not sure how we could go to the start of the conversation. Hold on a second. Fast glTF. Okay, let me try to find it though. I'm not sure if we're gonna go with this, but is this the one? Maybe. Okay, yeah, this is the one. Though I'm not sure if we could figure it out or not. Let's see. So, fast glTF is the speed and usability focused glTF2 parser written in modern C++17 with minimal dependencies. Uses SIMD in various areas to decrease the time the application spends parsing and loading glTF data by taking advantage of modern C++17 and optionally C++20. Also provide easy and safe access to the properties and data. Hold on there. The ability to directly write to map GPU buffers? What? Interesting. Oh, yeah, I see. And decomposing transform matrices. Though we don't have this. We cannot do this. I think. Yeah. Maybe? Not sure. Depends on how I implemented it. Because WebGPU doesn't really allow you to like write data directly, I guess. And decomposing transform matrices. To learn more about fast glTF, you can read the docs. I'm not sure if I can figure it out. I never worked with this. But I guess let's just give it a try real quick. If it doesn't work, we're gonna go with something simpler like OBJ or so it's capable of reading, writing. Oh, it's not capable of writing. Okay, I don't care about writing. Extension support, image decoding. Oh, tiny glTF can actually do that. Oh, interesting. Built-in drag code decompression. Android ASIC functionality, accessory utilities, sparse accessory utilities. Okay, let me see an example of both and then I'm gonna see which one I'm gonna go with. Though the problem with this one is that it doesn't handle image decoding, so we're gonna have to do it ourselves using some other library when we want that. So we'll see. So you create a parser instance. Well, let me actually zoom in. Here. Create a parser instance. Optimally, you should reuse this across Lloyds, but don't use it across threads. To enable extension, you have to pass them into the parser's constructor. Okay, across threads. Okay, great. So you have one parser for every thread. The glTF data buffer class is designed for usability of the same JSON string. Contains utility function to load data from std file system path. Copy from an existing buffer or reuse an already existing allocation. And then it has to outlive the process of every parsing function you call. That doesn't make any sense. It contains utility functions to load data from an std file system path. This loads the GLT file into the glTF object. Fast glTF validate method. Very interesting. Okay. It seems easy enough, possibly. Load the indices of a primitive. And here you give it like the type of the indices, I guess. Ooh, that's quite interesting. Okay, discharger. Fast glTF, the most used. Meantime parsing. Lower is better. Fast glTF. This is a linear scale, okay. Fast glTF, C glTF, tiny glTF plus rapid JSON. Oh my god. Okay. What is the license, by the way? MIT, okay. Great. So this is the bistro scene converted to GL using this. So there you go. Fast glTF, tiny glTF, and C glTF. Alright, I guess let's try this one, I guess. Does it have a CMake? Because if it doesn't, that's a no for me. Doloid CMD JSON. Seems good enough, I guess. What is the target call? I think fast glTF, fast glTF. Okay, great. Okay, let me see just the example of that is using tiny glTF, and I'm gonna decide on which one we're gonna go with for now, at least. So examples. Basic, yeah. I just want to basic mesh, right? So limitations. Who cares, anyways? So we have crazy stuff. What's up with this? Main.cpp, okay. And let's see how this is being used. So I guess this is how you load a model, seems like. So hold on. Okay, so you create a loader, then you load ASCII from file. Okay. If not, error.empty, failed to load glTF. Okay, and then how you do stuff with it. You go through all the buffers. Gen buffers, it's using OpenGL. Okay, yeah, seems simple enough to me. GL buffer data. Yeah, simple enough. Though, yeah, let's actually try to get it to work. I never used glTF before, and we're gonna give this one a try. If it doesn't work, we're gonna try tiny glTF. So yeah, let's go ahead and just do it. All right, great. CPM add package. Where is CPM? Okay, great. Okay, GH. It's called Spenda fast glTF. Okay. Let's grab this tag. And let's see. Hopefully we won't encounter some new bug, because this library seems like it's still new. And like something like tiny glTF, so hopefully it would work. Let's see. Great. Updating symbols, indexing module. And then let's link it. And how are we gonna link it? Well, fast glTF, fast glTF. There you go. Okay. So let me regenerate. Great. And then okay, so it's taking some time. Alright, so we have installed the library. So let's try. I have no idea where to even start with this. honestly. But honestly, let's start with Blender. Let's get a very basic shape going on. I don't have Blender yet. Interesting, I've just reinstalled my system, so let's install Blender real quick. Okay. Alright, let's go. Cycles render queue to support. Sure. Oh my god, no, that's gonna take a long time, I guess. Yeah, fine. Fine, choose. Damn, 2 gigs. Okay, so we're gonna download Blender. I forgot the fact that I have just reinstalled my system, so I don't have Blender yet. So yeah, let's install it. And while it's doing that, let's actually try to work on this. Let's see where to even start with this. Okay, so I'm gonna go to my constructor, I think. Main include app.hpp. Okay. And let's add a parser, a glTF parser. So examples, GL viewer. Oh, interesting. Okay, let's see. Fast glTF parser, fast glTF types. Great, let's actually add that. Hello Karim, alhamdulillah, welcome back to the live stream. Hello, how is it going? Any news? Okay, include fast glTF, and now let's see what we're gonna do. Great. Okay, let's do it here. So I'm probably the first YouTuber to try this library, I guess, but let's see. Oh my god, let's see. Let's give it a chance. Parser, okay. So we added the parser, great. So how do you construct it though? Fast glTF parser, okay. Parser, and then you can give it if you want some extensions, though we don't care about any extensions right now. Okay, what's next? We also have to probably initialize it, I guess. Well, let's initialize it, right? Well, honestly, let's call it glTF parser because we could have a lot of parsers. glTF parser. I never really tried glTF in my life, so let's see if I can figure it out. Bruh. Okay, let's go. So I think right now we should be initializing the parser. What's next? So we get the path and okay, so we have initialized that. Great. Next up, we're gonna need glTF data buffer data, and then we load it from file. Okay. Great. Let's see. Bruh. Okay. So before I guess GLW show window, let's actually load that up. So fast glTF data buffer holds a chunk of data that makes up the JSON string that the glTF parser will use and read from. Great. So load from file, and here we give it the path, which is in our case would be assets directory, and yeah, it would be models slash models, and let's just say slash, I don't know, box.gltf or glb, not sure, we'll see. And yeah, by the way, what they used here? Path. Where's the path? cpath. What is the cpath? Okay, I guess maybe it's in CMake or something. But anyways, so a restart is required for the change. Oh my, no way. Let's see if we can get Blender to run now. And let's see. And we got this little cube. No lights for now, no camera, nothing, just the cube itself. Oopsies. I don't want anything to get in the way. Come on. Okay, great. Now let's export glTF. And yeah, I wonder, did he use glTF or GLB? I don't know where he's getting this stuff from. Yeah, he's using GLB. Okay, great. So I guess let's use GLB. What about glTF? Oh well, let's try with GLB, I guess. So home, code.taco, great, okay, fine. And call this, I guess, cube. And let's go with C-line projects, probably, code.taco, assets. Here, let's create a folder called models. And let's try this out. Export glTF. Okay, so now we should have our glTF model called cube. Yeah, just open it as, I think it's close to XML. I guess. No, oh, it's GLB, I forgot. Yeah. I see. Well, let me export the glTF too, just so I have an idea of what's happening. Because I think it's human readable. So how gonna do that? GLB. Okay, so there's a lot of options though. There's GLB, there's glTF plus bin plus textures, glTF separate, there's glTF embedded. Export a single file, all data packed in JSON, less efficient than binary but easier to edit later. Export multiple files. Okay, let's go with this guy. I guess. Let's go with export glTF and let's see what it generated. Yeah, it generated cube.glTF. Maybe cube.bin too? I really don't know. Damn. I don't know if cube.bin is... Let's try again. Oh my god. Let's see. So yeah, let's just go GLB, please. GLB, where is it? Okay. And what they say about it, by the way. But more edific. Okay, great. Let's export that. So now we have cube.glb. Great. Now we're gonna load from file. Okay, let's see. .load from file. And here we're gonna say assets directory slash models slash box, or well, I called it cube. Okay, glTF. And let's see how that would go. So would this throw an error or something, or how does it throw errors? Let's see. Let's go back to the example. GL viewer. Okay, load from file. Let's go. Okay, next up we have to determine the glTF file type. Expected fast glTF asset. Okay, so it depends on if it's glTF or GLB. Great. Well, I already know what it is. It's GLB. So asset equal parser.load binary glTF from the data. Okay, let's just work with glTF as GLB. Oh, this should be GLB, by the way. And what's up with this? Okay, so this seems like needs to be in its own path actually. So let's go with that, I guess. CD file system path, and yeah, let's put it here. And I guess maybe auto-const asset possibly. And where's the parser? Yeah, it's called glTF parser. .load binary glTF. Okay, it's an expected type. Oh, expected. Oh, I see. So, and here we need the glTF options. What is those? glTF options. Let's see. Yeah, they're right here. So don't require valid asset member, allow double, load GL buffers, load external buffers, load external images, blah blah blah, generate mesh indices. Okay, let's just copy those for a second. Here, I guess, or whatever, and let's see where all these options. Oh my god, how much options there is here. None, allow double, don't require valid, load GLB buffers. Load external buffers. Okay, this is interesting. What does this do? Let's oh, I see. Great. Load all external images. It does not decode any texture data. Complementary to load external buffers. Okay, great. Minimize JSON before parsing. Okay, this seems good enough. Don't require valid asset member. This skips validating the asset field as it usually there and not used anyway. Okay. Allow double as an accessor component type. Not listed as allowed component type in glTF spec. These component types. I don't think I need this. But well, anyways. If disabled, will only provide a byte offset and length into the GLB file. I'm not using direct storage or metal IO, so that's fine. Load external buffers. Okay. Anyways, so this should be fine. Great. Now, what's next? If asset.error, then, well, error. That's basically it. So if asset.error not equal to fast glTF error none. Okay, STC. Yeah, let's actually throw and fast glTF get error message. This is the important bit. And yeah, let's just, I guess, throw std runtime error plus fast glTF get error message. What's up with this? What this returns? A basic string view. Okay, so we need to allocate it, I guess, so we could add it together. There you go. And yeah, so let's see if it would even succeed in loading it though. Uh-oh, what's up with this? Oh, this is just warnings, okay. Great. So I guess we have successfully loaded it. All right, now we gotta see how we can do this. So viewer asset std move asset.get. Okay, so you could get the asset, and in that case he's moving it. Great. So let's say auto probably cost, not sure. As, or well, I guess let's call it maybe mesh, and let's say asset.get, and this gives us, returns a reference to the value of t. Okay, but what's up with this? For call what dot get. Okay, why does this doesn't work out? Let's see. Oh, you actually have to give it something, or what? No idea what's going on with this. Okay, what is the asset is actually, what type it is. I guess we could find it maybe in HPP or something. No. Oh, asset, like, oh, there you go. glTF asset. Let's call this glTF asset, I guess. What? I'm confused. Fast glTF as asset, and for some reason he's moving it. Yeah. What? I don't get this, bruh. I'm gonna copy exactly what he's doing. Let's see. I'm very, oh, maybe it's because it's oh my god, I see. Damn. Previous definition is here. Oh, redefinition. Yeah, let's call this mesh, I guess, or something. And yeah, let's go. So now we got the mesh or whatever. Now what we could do with this. Accessors, animations, asset info, available categories, buffer views, buffers, cameras, default scene, extensions required, extensions used, images, lights, materials, meshes, and nodes. Ooh, interesting. And here, what meshes is though? I guess it's a, yeah, it's a vector, I think. And yeah, you could actually say the name, maybe. But yeah, let's try to at least, you know, log some info just so we know that at least we're getting something. What's up with this? Type optional, does not provide a call. Yeah, how do you, I think you do it like this for optional to unwrap it in C++. Okay, what's wrong with this? Does not provide a call operator. What? I'm confused. Does not provide std optional. Bro, what's up? Mesh asset info. Okay. Rich. What about now? Okay, we got the copyright, the generator, and the glTF version. Okay, what about this? For example, let's see. Let's start small. Can we just maybe print the whole thing? No, we can't. Okay. Super slow. Uh-oh. Let's I guess it doesn't have an asset info, maybe. That's my guess. Yeah, probably. But why it doesn't include it here? Interestingly. Oh yeah, I don't think it have an asset info, that's why. So anyways, let's just get into to work now. Let's just say mesh dot I guess accessors is what we need, maybe. And this is like, I guess, a vector, is it? Accessor, yeah. And there's an accessor type, count. Okay, that's the accessor. Okay, let's see how he's doing it here. Is he using that thing? Well, let's check out his documentation instead, honestly. The documentation seems nice. Overview, I guess. Let's go, usage. Okay, so he have done it like this. So for auto buffer, what about accessors? He talked about it later on. Yeah, there you go. Primitive. How can I get access to a primitive here? Primitive. Interesting. I have no idea what I'm doing. Oh, there you go. That's the primitive. So you say primitives 0, let's say. And then we could say material index, indices, accessor, targets, blah, blah, blah. Well, scdc out mesh dot primitive. Well, what is going on here? Yeah, meshes, right? Meshes dot size, exactly. Let's see if like how much meshes we have. I think it should be 1, but you never know. Let's see. This is super slow. I guess we're gonna need some scripting thing. Yeah, we got 1 mesh. Nice. Okay, so what if I try to print mesh 0? Can I do that? No, I can't. It does have a name. Okay. Oh, my bad. I have a debugger and I'm using cout. Come on. What a stupid thing to do. It's called the cube. Okay. My bad. I have a debugger and I'm using cout like a stupid. Anyways, let's see. Let's see the whole thing. Using the debugger. Great. Alright, so here it is. We got the mesh, right? Yeah, there you go. So we got the asset info, which is none, I guess. It's not there. Extensions used, nothing. Extensions required, nothing. Default scene. Well, dummy. Weird. Okay, accessors. So we got actually 4 accessors here. We got accessor 0. Okay, and it's a float. By offset 0, count 24, type vic3, and component type float, normalized false. The name, it doesn't get any name. And then there's max, what's that? Min, yeah, I would guess maybe the bounding box, possibly. or like actually just the max and min of those specific attributes, whatever it is. Value 0 for some reason, no idea, and the dummy. Okay, and 1, it's vec2 float max and the min. Buffer, oh, there, this is called buffer view. Oh, never mind. Buffer view index. And 2, this is a vec3 and 3, which is a scalar in sign short. Ooh, I would guess maybe this is the indices. Like this one is vec3, this one is vec2, and this one is vec3. I would guess the first accessor is probably the vertex positions, and this ones are probably texture UVs, or UVs basically, and I would guess these are normals maybe. Walaikum assalam DG123, welcome back to the live stream. Okay. Normalized, all they're all false. And yeah, and I would guess these are the normals maybe. And then is that correct? Like vic3, how much it is? A vic3 I would guess is like 3 floats, and the float is I think 4 bytes maybe. Is a float 4 byte or what? I think it's a 4 byte. And well, 24 divided by 3, how much is that? I guess 8 maybe? No, hold on. Let's see, just make sure. 24 and divided by 3, 8, yeah. 8, 8, 8. Okay. But anyways, so what's next? There's animations, which is empty, and there's buffers. Oh, right. So buffer 0, byte length 840, and then this is the data. Contained value, mim type or whatever, glTF buffer. And yeah, here's the data of this buffer. In sign chart, these are bytes. Byte length 840. Interesting. And then there's the buffer views. Buffer index, buffer offset, byte length. I guess maybe with the glTF we could have got a name so it would tell us which buffer is which. Maybe. Array buffer, byte stride. That's crazy. Cameras, of course, nothing. Images, no. Lights, no. Materials, there is some PBR data, right? Nice. From Blender. Cool. Very cool. And then there's meshes. Oh, right. This is what we wanted. There's primitives, 0. And there's weights. No, there's nothing. And the name is cube. Okay, great. So this is our little cube. So the attributes. Okay, so these buffers, those buffers I think are for the whole scene. Yeah, I mean, that makes sense. And then we got here the type of triangles, basically. Yeah, great. And then targets, nothing. Indices, accessor, we got a value of 3 for some reason there. Anyways, this is probably like a private thing. Yeah, material index, probably same thing. Anyways, attributes, size 3 and capacity 4, and then the data. Position. Oh, okay, so the first attribute and the only attribute is position, I guess, or isn't it? That's the first. Okay, very interesting. What is nodes? Oh, I guess maybe these are private or something. Not sure. And there's one scene. Node indices, and then there's skins, textures, nothing there, and then memory resources. Okay, so we have checked this out. Great. Now let's try to get something actually working. We got a little overview of what's happening there. And basically here we got primitives. Let's try to get some primitive, just like you have done here, fast glTF primitive. Okay, so well, let's just say fast glTF so we don't have any surprises right now. Primitive, and let's say mesh dot prim mesh, well, let's just say equal to primitive 0. Okay, great, we got that out of the way. Now we got the first primitive, which I think is the only primitive, isn't it, that we have? I don't remember. Come on, bro. What's happening? Well, let's run this again. By the way, guys, you can actually join my Discord server to chat in VC, and everyone can hear you too. There. So what's happening here? Okay, so let's go to meshes, our mesh, and meshes 0. Well, that's not mesh, right? That's the whole scene, kind of. Yeah, not even scenes, asset, basically, right? Makes sense. And then primitives. Yeah, we only have one primitive. Okay. And yeah, we only have one primitive. Great. So that's it. And this is not mesh, this is actually asset. And I'm not sure what to call this, but maybe a raw asset or something. Right, raw asset, and then this is asset dot meshes 0 dot primitives. Great. Now how we can get the data out of this? So he have this thing right here. Let's try to see if this would work for us. So he got indices, a vector of UN32T. Our indices, are they UN32T or UN16? I would guess 16, but yeah, 16, okay. So I would guess here I could say, or I could too simply, I guess, say decal type, well, yeah, decal type of indices. Ooh, I see what's happening here. Well, I have that global indices, oh, it's called index data. Okay, great. It's called index data. Index data, and then we're basically gonna get the value type, which is inside short. Okay, great. So it would basically always match. If primitive dot indices accessor has value, then auto accessor asset. Okay, so this seems wrong. We gotta change it to this. And then, well, in our case at least, accessors primitive dot what? Yeah, I see. Great. Dot value. Okay. Indices dot resize accessor dot count. Great. Now what's happening with this? Iterate accessor with index. This doesn't seem to be there. Oh, there's fast glTF tools. Iterate accessor with index asset.get indices index. Okay, let's try to import this, I guess. There you go. It's working out. And no member named get in asset. Yeah, because you just gotta say asset, I think. comma accessor indices, and of course this should become decl type index data value type, I think. And same thing here. And yeah, index and IDX. And hopefully right now we got some indices if we have done everything correctly. Or actually, let me just debug here and see if we actually got that or not. Moment of truth. Okay. Asset assert what? Where is this? Oh yeah, it's became a raw asset. Okay. And here too, raw asset. Okay. Now the moment of truth. Let's see if we got our indices buffer or indices data. Let's see. Okay, so we got indices here, and I mean, seems correct to me, but does a cube have 35 indices? No idea. Well, depends, right? It depends. So like, well, these are not just the vertices of the cube itself, but like all the triangles. So possibly, I guess. But so how can we actually collect the other data? Right now, we just need the vertex, the actual vertex data. So we got the indices. Great. Accessor tools. Let's go. Let's see if we can find some example here that does that. So there's only index accessor stuff, access iterators. Yeah, there's some cool stuff here. Well, I think it's probably similar, probably very, very similar. So let's just try to wing it, I guess, from the previous one. So here we gotta get the vertex data, I guess. Well, honestly, what I'm doing, bro, hold on. What I'm doing, we're gonna remove this index data thing here. So yeah, just say using index type, let's say, is equal to I guess UN16T or something like that. Yeah, let's just say that, and here we're gonna get this, and they're gonna get this. We're gonna get this. Okay. So what's up with this previous to finish? Okay, great. Now we're also gonna need some vertex type. Well, we already have a vertex type, which is the actual struct, isn't it? Well, not really. Depends though. Yeah, it really depends. But we're gonna go with, yeah, how would you do it actually? Like how vertices in Blender are, let me see. Or maybe I should actually check out glTF spec or something. glTF vertex data or something. Let's see. Provide an outer bounding box for all the given accessor. For example, all the vertices of particular primitive and then bin will offer the bounding box. Yeah, as I expected, the bounding box. From box texture.gltf, nice. So there's some attributes. There's normal, position, text chord, and there's some indices and the mode, the material, and the name mesh. Here's a sample of start of accessor 0 from this model. And this is a sample of the contents from the start of accessor 2 in this model. Okay. Oh well. Interesting. So there's indices accessor. But yeah, how do I access the actual vertex data? There's material index, targets, type, and there's attributes. Huh. Oh, attributes. Okay, let's see how he have done it. Maybe here. Let's see where he, yeah, there's the VBO here. He's using OpenGL. Gen buffers, bind buffer, buffer view.target. What? Oh. Buffer view is model.bufferViewsI. Ooh. So he's going through every buffer view. Okay. And then he's basically creating, I guess, a new buffer. And then what GL bind buffer takes I guess maybe the type of the buffer or something. I don't remember. And even when I was using OpenGL, I was usually using DSA. So GL enum target. Yeah, okay. I see. Well, interesting. Great. GL array buffer. Copyright. So it's either array buffer, and yeah, we have actually noticed that it's an array buffer, right? Read buffer or copyright buffer or element array buffer, pixel pack buffer, and stuff like that. Great. Now I see what he's talking about. And then he's filling up the buffer with data. He's doing the buffer data target to bind to it. Then byte length, buffer data add 0, buffer view, plus byte offset. And then GL static draw. Buffer.data add. Buffer is model.buffers. Okay, so right now we need the buffer view first, seems like. So I guess basically buffers are just like big buffers basically, which actually contains the data, and then buffer views are just like telling you which chunk of that data, I guess. Maybe, but anyways. So we don't need this here. Let's just say, I guess, std vector, and our our goal is to just fill up this up with some vertices, some sweet vertices. Let's go. Let's see. So we're gonna go through, well, in fact, let me just debug and see how we can. I'm just gonna hard code this now. I know the mesh that I want to target. I'm just gonna hard code it until we get some results first. Then we could implement it properly, because I never worked with this before. Let's see, vertices. Okay, so let's go to primitive, I guess. Why it's optimized out? Oh, okay, but we aren't debug. Why optimize it? Weird. But anyways, we need asset. We need skins, textures, meshes, samplers. We need buffers. Yeah, buffer views and buffers. So buffers, we have one buffer. It contains basically all the data of the mesh, I think, or the whole scene, probably, or maybe something like that. I don't know. Okay. And then we got the buffer views, and then it have a target, and the value of that target is fast glTF buffer target array buffer. All right, I see. Array buffer. What's this? Array buffer. I don't know why it's this. I don't understand why there's like 4 buffer views. We just have one little cube. But anyways, so it seems like I just have to do it. There's no way. And then there's some byte stride. that doesn't seem to contain anything interesting, I guess. Anyways, let's just do it. Okay, let's go through all the buffer views. So for let's see, auto const or what? Buffer view, how he's doing it. Let's see, buffer views dot size. Okay, so auto const buffer view primitive dot buffer views, I guess. Well, not primitive, it's gotta be mesh asset actually. Dot buffer views, right? And then okay, great. So now we have gone through that. Nice. So for every buffer view, we're gonna create a new buffer. Is it? Well, first we need to fetch the buffer that this buffer view actually references. Okay. Auto const reference buffer assets buffer view dot, I guess, buffer index. Yeah, probably. And yeah, now we have got the buffer that it's actually referencing. Great. Now we gotta basically create some buffers. Okay, so in fact, instead of this, we gotta say cd vector of WGPU buffer. In fact, I think vertex buffers. Well, not really, but I don't know really. Anyway, let's just call it buffers. I don't know what's up with this. This is weird. Okay. And if buffer view dot target is 0, then we're just gonna skip it, I guess. Just to make sure we don't get any weird stuff. Impl draw arrays. Ooh, draw arrays, interesting. Well, it's probably an enum or something like that. Target, buffer target, element array buffer or array buffer. Well, it's basically 0 static cast essentially, I think. Yeah, let's see. Guess that's how it's supposed to be. Draw arrays function should be used with a count equal to the count property of any accessor reference. Draw arrays and supported buffer view. Okay, fine. And do we have any unsupported buffers? Oh, well, let's see what I'm missing. Bruh, come on, are you kidding? Bruh, it's take ages to compile. Okay, so we don't have any unsupported buffers, so that's nice. Well, let's just remove this for a second for now. And yeah, let's just see. So what we got here. So we gotta create a buffer now. Okay. And how you create a buffer is by doing, where we're creating the buffers. Oh, okay, there you go. So we gotta do something similar to this. Come on. Okay, so descriptor, and here we got WGPU buffer. Let's call this glTF buffer though. We're not using it just yet. So here we got this size in bytes. Let's remove that. And in fact, let's even remove this. We could just say as const btr WGPU buffer descriptor, and here we got the buffer view dot byte length. And how do we gonna know the usage? No idea. If not index buffer, well, in our case it's gonna be just a buffer. Well, we're basically gonna add it to the buffers. Right. Well, we could in place it. Well, can we really do that? Let's just push back for a second now. And if not, actually no, go back. Yeah, just like this. I'm just gonna say WGPU buffer. Okay, let me just remove this. Great. So if not the buffer, then we're gonna throw fail to create WebGPU buffer, and then write buffer view dot byte length, I guess. Buffer and use of indeclared identifier size bytes. Ooh, what's this? Oh, this is the actual data, I guess. Yeah, probably. Yep, the data. So where we could actually get the data now? Let's see, byte length. So you say buffer data at 0 plus buffer view dot byte offset. Ah, okay, I see. So buffer dot data. Oh, oopsies, glTF buffer in this case. Dot data. And then we basically kind of need to say plus, or let's say at 0. Is that how it goes? Well, you need the, I guess, the reference here. Well, that doesn't make any sense, does it? But add 0 is not there. What in the world? Buffer. Well, let me just make sure I have the correct type. Oopsies, here. Oh, what the? Oh my. What in the world? I'm using tiny. What? How? That is crazy. I thought I was looking up the example of the other guy, but I'm looking up the example tiny glTF. Oh my. That is another level. Yeah. I don't know. It's crazy. Anyways, GL viewer. Okay. So this is the actual thing. Oh my god. Let's see, buffer data or something. Yeah, here's yeah, this guy is using DSA, so that's lovely. GL create buffers. Yeah, okay, that's nice. So he's creating the buffer holding all of primitive structs. Ooh, that's crazy. Create the material uniform buffer. I'm talking about the vertex buffer, where it is. Vertex. Create vertex arrays. Weird. Well, I'm confused even more. Yeah, there you go, the position. Alright, let's go. That's nice. So here he's using some position accessor, I guess. So asset the accessor's position IT second. What is this position IT? Okay, he's going through all the primitives. In our case, we only have one primitive. And then he's finding the attribute position. IT find attribute position. Well, honestly, let me just copy this. And let's try to basically try to translate it to what we want. So let's see. I'm just gonna comment this out for a second and let's see. Okay, position accessor. We don't get position IT. Where is position IT? Right. We only support index geometry. What this does? Yeah, mesh primitives resize. Oh, he's finding the. Oh, okay, hold on. So if I say find attribute, well, let's actually paste this in. And what happens if we say primitive dot, I guess, find attribute. There you go. Position, I guess. And what's up with this? Cast expression to inside long. What do you mean? I'm very confused. Required to hold the position attribute. Oh, he's saying second. Not sure what does that do, but okay. Great. So if not position accessor dot buffer view index dot has view value, then continue. I see. I'm just gonna, let's say, throw. Then he's enabling vertex array attrib format. Alright, so we gotta change the vertex layout depending on that thing. Interesting. GL vertex array attrib format. He's enabling the first attribute and he's getting the number of components. Okay, I see. Of the position accessor, the type. Great. So let me try to extract these data. This is the number of components. So let's see. Okay, auto const components count, I guess. Something like that. And what's this? Returns unsigned char. Okay, and what else? There's this fast glTF get GL component type position accessor component type. Okay, so this is the actual component type. Okay, the const component type. Okay, how does do it to underline type? What is this? But basically it's component type either invalid byte, unsigned byte, short, or what exactly? Alright, nice. So yeah, let's just get the component type itself. And we got the number of components. What else do we gonna need? Attrib binding 0. Okay, so these are all the information there. Now we got the asset buffer views, position accessor dot value, offset byte offset plus position accessor. If position view dot byte stride has value, then he's doing this, otherwise he's doing this. So what's the difference there? Well, position view dot buffer index. Alright, well, we got indeed the buffers here. Oh, we should go through all the buffers. Well, depends if it's like buffer index. What exactly? I see. That is crazy. Well, for now though, let's just say 0. Buffers 0. Or honestly, let's just say vertex buffer. Or position buffer, actually. This is gonna be the buffer position, it seems like. Right, position buffer. And where's buffers now? Let's remove these and let's just say we got a WGPU buffer, which is gonna be a position buffer. And this is gonna be device. Oh, create buffer. Can I actually create it? No, of course not. Yeah, no. Well, create buffer, and then we can say as const ptr buffer descriptor vertex, and then here, well, we do need the size though. Interesting. So how are you gonna do that? Where he's even creating the buffer. Interesting. So here basically is creating array vertex buffer. And so what's the difference here? So if it has a value, he's doing this, which means he's using the byte stride here and the offset here. Oh, okay. Otherwise, he's using this. Alrighty. And do we got, okay, great. So let's see. Else std out, cout this, I guess. Otherwise, we're gonna go with this. Yeah. std cout. And for this though, there you go. And let's just, I guess, say something like this maybe. And dash w no error. How can I remove it? Let's see. Target compile options. Let's add it here. Say dash w no error. Oh, I stopped in the wrong place. Okay, let's go here. Well, here. Ooh, what? It didn't reach that. Are you kidding? How? How could that be? Well, let's say this. What? Are you kidding me right now? Why it's not getting here? Finally, so what was happening here? Okay, position accessor, let's go. All right, let's see. Component count 3. So it did indeed find a position, nice. It's a float, great. And what's next? Position view. And it doesn't have a stride. Great. So we're gonna go with this. Byte stride, okay. Great. So honestly, let me do something here, which is bytes try dot value. So I guess we could say this, and then we could say this bytes tried is equal to that. Otherwise, bytes tried is equal to this. And there you go. Now we could actually, let's say, log that. Okay, just continue. And let's see what it have logged. 12. So the bytes tried is 12. Okay. So 12. And we got 3 components, right? Yeah, we got 3 components. So 12 divided by 3, which is 4 bytes. Yeah, and that makes sense. Makes sense. So let me just see. Okay, great. So the bytes try 12, and the components count. Why this time? Why? Bruh. This is stupid. Well. I gotta use it so it doesn't get optimized out. What a joke. And let's say component type. And let's say, well, let's just say component count. I already know I just want to make sure I'm doing this right. So 12.3. Okay, great. So float 12.3. Well, makes sense, right? Okay. So I'm not sure about color. Yeah, I'm just can leave it, I guess. Yeah, I could leave it. But well. Yeah, let's just remove color for now, I guess. And let's just keep the position. And now we gotta change this, so it's gonna be vertex attribute only 1. Vertex attribute float 32 times 3 because it's gonna be 3D. Shader location 0. Great. What's next? So we're not gonna have any colors anymore for now, at least. And yeah, great. So we got these. Great. Now let's go down to where we're doing that stuff. glTF data. Now here, what we got? We got the position view, buffer view index, and we got the offset. And what else? Do we got the size? I think. Oh, byte length. So we could actually make that buffer now. So let's go ahead and do that. We got everything we need, I guess, to create it. And this, we're just gonna call it vertex buffer. Device create buffer. It's gonna be vertex, of course, though it's also gonna have WGPU buffer usage. Copy DST, and then it's gonna have the byte length here. Oh, we were already doing that. Great. Buffer views. But let's just say this, just to make sure. Position view dot byte length. Now we gotta fill this somehow. So how are we gonna fill it? Let's see, if not vertex buffer, and then here Q write buffer. Okay, let's see how he writes at the buffer again. And the cord of the microphone is getting in my way again. Let's see, array attrib array vertex buffer. Yeah, where he's setting the data. GL buffer data or something? Named buffer data, right. So he's doing it here, holding all of our primitive structs. And here he's doing it to do what? He's going through every buffer. Huh. Named buffer data. Vector.bytes dot data. The example should be quite simple, not this crazy stuff. But anyways. But let's see. Q write buffer. So asset.buffers position view.buffer index. Asset.buffers position. Don't we have the buffer already at this point? So he's getting the buffer. Great, then he's taking the data of that buffer. And he probably needs the address of that plus the offset. What data is? Data source. Weird. And what is the offset? Byte offset. Well, I'm gonna make sure that this is in bytes, honestly. So std, well, not std, static cast. Char. Or reinterpret cast or whichever. What about reinterpret? I don't know how, if this is the correct way to do it, honestly. But yeah. Plus offset. Right position view dot byte length. Great. I think that's maybe it. But let's change our shader. And hopefully we could get something working there. And I don't know if they're using counterclockwise or clockwise. And oh, did we actually did the same with the index buffer yet? No, we probably haven't updated that yet. We'll see. Anyways, so first thing first, I'm gonna remove this color from here. basically, and the vertex input would be vector 3f. Essentially, for now, we're not gonna have any vertex output at all, I think. Or yeah, let's go with no vertex output probably. For now, or let's just maybe comment this out for a sec. And what else? So vector 3f uniform, that wouldn't change of course. And here we don't have any color anymore, and here I'm just gonna hard code some color. Let's say 1.0, 1.0, 1.0, whatever. And then what else? Out.position, vertex output. We don't have any vertex output anymore. Well, we do, yeah, we do. Oh, what? Oh. That's weird. Yeah, we don't need this stuff anymore, right? Basically, and yeah. Actually, we do, right? We do. Never mind. So built-in position, out.position equal to vec4f. Well, in our case, it would. Why do we have 4f? Oh yeah, okay. All right. Yeah, that's it for the shader. Now let's make sure we update the index type accordingly. So for the indices here, we're saying indices index blah blah blah, whatever. Now here we need to update the index buffer. So where we create the index buffer, let's see. Index data, vertex data. So I guess we don't need these anymore. Yeah. Oopsie. And all right. And what else? Let's see. So we don't need this hard-coded data anymore, hopefully. We'll see. Vertex data. Let's hope that works. Bro, what's up with this? Oh, there you go. Okay, so vertex attributes, that would still be for now hard-coded. So yeah, offset of vertex position, blah blah blah, size of vertex. Okay, great. So now what? Let's go down. glTF. So here we're creating the actual buffer, the vertex buffer, and we're writing data to it. Now same thing here, we're gonna create the index buffer. Device create buffer, indices.size times size of index type. Great. Oh. Okay, makes sense. So what's next now? If not index buffer, runtime error, and now write buffer. Indices.data, indices size times index type. Oh my god, moment of truth. I don't think this would go right. Well, let's see. Bytes tried. Set but not used. Come on, this is so annoying. Position view is not declared in this scope. What? Ooh. What I've just done. Oh, I see. Was not declared in this scope. Index data.size. Okay, I see. Well, can we say maybe index buffer possibly dot size? And let's find out. Oh my god, let's see. There you go, we got nothing. Oh my god. This is gonna be fun. I have no idea where to even start to find the bug. Or the bugs. Oh well. The first thing that comes in my mind is calling. So let's try to disable that. Like, yeah. Let's just disable that. None. If this doesn't work, I really have no idea how to make it work. And yeah, it doesn't. Amazing. Oh well. Oh, hold on a second. Hold on. I think maybe yeah, I see. Great. Well, hopefully this would fix it. Oh my god, let's see. Right. So because it was vector 2. And yeah, nothing. Great. Oh my god, let's see. Well, that is crazy. In position, uniform time. Vertex output out position. Position vec3 f. Oh, okay. Well, this is vertex output. So vec4f, and the vertex input is vec3f. No idea what was wrong. Well, input maybe dot x input dot y and input dot z. Let's see. Nothing. Yeah, epic failure. Let me double check other stuff, I guess. Back, front, none. In define triangle list. Oh my god, what's happening here? Victory position. Could this be the problem? I wonder. Hello, what's up? Oh well. Yeah, we got nothing, and I have no idea what went wrong. WGPUs suck in debugging. Like, it gives you no error when the shader compiles or something. Fails to compile. Yeah, I really don't know what could be wrong here. Damn it. Vic2 index type. Still waiting for sub 10-minute Falcon Triangle speedrun. That's probably coming. I'm getting frustrated by WGPU debugging abilities. And documentation. But anyways, have you been much of a gamer? Kind of. Not much though. Yeah. Well, that didn't seem to work. I have no idea what could be wrong with that. Yeah. No idea. Anyways, so I think I'm gonna take a little break, 5 minutes break, and come back. Hello. Okay, I'm back. Let's go. All right. Let's see. Okay. I'm gonna try one little thing more, and then we're just gonna go back. Okay. Let's try one last thing, which is to fix this type because it's not the same. What else? Does this size give us the size in bytes or? Ooh. I guess it gives us maybe the size in bytes actually. Yeah, possibly. So let's say times 4 bytes. Okay. I don't think this would work honestly, but let's just see. Yeah, I know. Okay, what about you in 16? And then times 2 here, because 2 bytes in 16. And what else? Let's see. Where's the type? There we go. This gotta be 16. And oh, indices. Okay. Alright, let's see this one too. Yeah, honestly, I don't think it would work. Yep, nope. So yeah, not sure what we're gonna do now. I guess maybe we can fall back on either using tinyxml and see how that goes, or probably we're gonna go with obj instead. See how that goes. Probably obj honestly, because glTF seems a bit involved. So tiny glTF, this is what they do. They bind the buffers, buffer data, gl static draw, then attrib first, compare, blah blah blah. What about WebGPU glTF or something like that? So something that would just create the buffer for us or something like, I don't know. Let's see, there's this guy. So much lag. Oh, why? Seems good to me. Like my software doesn't say anything about that. It's excellent, I guess. Can someone else confirm? Yeah. Oh, interestingly here they're rounding the buffer size up to the nearest multiple of 4. I'm in Hong Kong, so probably maybe it's on purpose. Not sure. Byte length. It's actually doing this interestingly. get mapped range set. I'm near China, so probably, yeah. So primitive pipelines. GPU format for accessor to byte offset. Yeah, I know. We could try it later on. This is a lot. So it's just gonna go, I guess, with OBJ maybe. Yeah. Let's try OBJ, I think, instead. It would have been nice if it worked, but well, what you gotta do. Let's see. Okay, let's roll back this stuff to the latest working version. And let's get back our beautiful triangles. There you go. Okay. Oh well, that was a lot. So let's try OBJ instead. So there's some good OBJ library in C++. I wonder. OBJ. Two 2021. This name seems like I've seen it before somewhere. Maybe in the Discord server of graphics. August 2023. Okay, how you do it? Let me see examples. And come on, why why the examples always have to be crazy thing? I don't know, it's weird. Like, why can't you just show something very, very damn simple? I don't know, it's crazy. Like, bro, this is an example? Well. I mean, it's OBJ, it should be very, very simple, but... yeah, it's using this. So let's see. He's loaded in some textures. Here you got the indices and the vertices. Great. He's binding an index buffer. You enter it to. Should change the type of the indices from to, because there are going to be a lot more vertices then. Okay. The case CMD bind index buffer. Tiny OBJ loader. Shapes, Lloyd OBJ, materials. We don't care materials right now. I just want to. Okay, so this could give us the indices. Interesting. Pushback indices.size, vertex.pause, attribute.vertices. Oh, these like the component count. Okay. Times plus 0 plus 1 plus 2. Alright, this seems pretty simple, right? I guess. Vertex deduplication, we're not gonna do this crazy stuff. But like, yeah. Let's keep it simple. Alright, let's see. I guess this should be simple enough. So I guess let's do it. Alright, so CMake list. But the first thing before we do this, I'm gonna change some things. Which is I'm gonna make this 3D position. So let's go ahead and do that. So Vic2 position. Instead of that, it's gonna become Vic3. And hold on, let me actually generate the OBJ first. Export OBJ. Very simple cube right there. And C-line projects. Go to Taco assets models. And I'm just gonna call this cube. And okay, let's see. Forward axis, blah blah blah. Apply modifiers. Geometry, so I could include the UV coordinates. I don't need that now. I don't need normals either. And triangulated measure. I do need triangles. Materials export. Don't export any materials. And yeah, that's pretty much it, I think. So let's try that out. Pretty simple stuff. And cube OBJ. Alrighty, nice. So these are the vertex data, I think. And then S0. I would guess maybe this is like the mesh 0 or surface, yeah, surface 0. And then maybe these are triangles, I guess. Like indices, triangle indices, maybe. So yeah. Yep, let's see. Okay, I guess this should be quite simple. So we don't need color anymore. Let's remove that for now. We could always take it back, but for now let's keep things very simple. And let's see, vertex buffer layout, vertex. Oh my god, this could have been the problem that we had earlier. Damn it. Well. Anyways. Yeah, indeed. That could have been a problem. That's stupid. Anyways. I should have probably gone with a vector instead and call it a day. But anyways. Vertex buffer layouts 1. And now we got the vertex data. Now this would actually go away because we're gonna load these at runtime now. And let's go. So where we're creating the vertex buffer stuff, there you go. So we're gonna need the vertex data somehow, and we're gonna need the index data. Great. Well, honestly, I need to try this first to make sure that it works first of all. So let's go ahead and do that. UN16T, great. Copilot did a good job there, nice. Let's remove the color. And now, did we change that? No, we didn't yet. So, okay, great. Alrighty. Let's remove the color too here. And let's just do this. Index data. Oh yeah. Let's just hard code it now and let's say 3 vertices. And we're not getting anything. What? Maybe it's the problem of call mode. Let's just say none so we don't have to deal with this anymore. Okay. And oh, my bad. I see what could be the problem here. Hold on. Yeah, I remember. So keep this as it was, but the problem that I think we have here, yeah, let's go. For now, we don't have any color, so just gonna say this. Okay. Have you guys ever tried loading OBJ and glTF and crazy stuff like this? Okay, why it's stupid? Oh, well, I see. I very much hate the fact that it doesn't give any errors. And what's up now? This is ridiculous. Position Vic 4F. Yeah, this is very ridiculous. Let's say none. Like what? Let's scroll back. And let's start by changing the shader first, honestly. What's wrong? Don't remember if I've ever used 3D models. Maybe like 10 years ago. What's wrong? Let's just start listening. We have tried glTF. We have tried to set up glTF for 2 hours, but at the end it didn't work without any errors. And I just hate debugging WGPU now. I very much hate it. So probably gonna go back to Vulkan. At least I know what I'm doing there. Anyways, let's see. Now I'm gonna try to hopefully use OBJ instead. Let me remove the color now. Color, remove that. And what else? Remove this. And here, just hard code this. And yeah. And the other thing, we're gonna remove the attribute from here. What? Oh yeah, gotcha. Okay, and let's remove the color, and let's make sure to change this guy. And yeah, now let's just change this. Let's remove them. And let's see. It should work just fine. Okay, great. So now we remove that. Great. Now this, instead of having this vertex data here and this index data here, we gotta put them somewhere else, because we need to change them at runtime. So let's go down to vertex buffer. And let's put them here. And let's convert them into a vector instead. And no need for const expr. Here is std vector. And uint16t. And you got the index data. Great. And that's, but we should Now we should remember something, which is, let me just say here, size of decal type vertex data value type times vertex, because right now we have a vector. So it's not in the stack. So because if you do size of decal type, just going to take the size of the vector in the stack, not the actual heap, not the data itself. So just the data structure behind it. But anyways, so here we're gonna need the same thing, but just instead of vertex data, we're gonna go with index data. Great, lovely. And what's next? Now let's see if this still works. Yeah, index data was not declared in the scope, I see. So just hard code this here for now. Well, honestly, I'm gonna make it a variable so we could prepare for that. Great. Here, until now we're all good. Great. Now I'd like to actually store the indices count. So let's actually store that, because we need it to actually know how much to draw. So let's see, that's gonna be, let's say it's ICT or uint32t probably. 32t index count or indices count. Yeah, let's go to index count. I think that's how English works. Okay, right, nice. And here I'm just gonna say that index count is equal to index data dot size. Lovely. And now instead of hard coding that, we're just gonna say this. So we're just preparing for the data to be like dynamic, so we could load it at runtime first, so we don't do the same mistake as before of having to do everything at once, which of course would never work. That's why I constantly keep on testing incrementally, just so I don't end up in such a position where I don't know ever what could be the problem. But if you change one thing after the other, step by step, it's pretty easy to catch down what's the problem, which is literally what have you changed last time. So but anyways, so as you can see, it works. Now it's just a matter of actually filling this vector with vertices and stuff like that, and indices somehow, whether using a glTF and OBJ, we don't care. Either way, we have to do this. So yeah, lovely. That's what I want. Now we need, let's say, a library. Great. Let's start small with tiny obj, because glTF didn't go so well. We have spent like 2 hours just battling with trying to understand what is going on there. But anyways, but yeah, all that complexity, because glTF is not just a mesh format, it's like it can hold a whole 3D scene in it, and it's meant to be very flexible and also very efficient. So it makes sense that it have all that complexity. So I probably have to actually go ahead and read the glTF spec first, so I can understand what the heck is going on there. But anyways, so yeah, let's actually add this guy now. CMake lists, great. Now let's add cpm add package. GH tiny obj loader. Let's grab the latest branch. This is how easy it is to do stuff in CMake. Pretty simple. As long as the library, whoever created the library CMake file, is knowing what he's doing. So yeah. What is the CMake target name? target, well, add library name. Great. Library name is called use double. It's off by default. Okay, so it's called the project name. Great. So it's basically tiny obj loader. Okay. How can I do this now? Target link libraries, and we're gonna add this tiny obj loader here, and let's go. So this should download the thing and set it up. Let's just build this now. It's gonna build the library, and then we could actually go ahead and use it. Alrighty, nice. Let's see if we can find some documentation in this tiny obj loader or something like that. Let's see. I don't know why the examples have to be very complex all the time, but anyways. It can only handle faces, lines, not points, not curves, not surfaces, I guess, and stuff like that. Anyways, PBR material extension. Usage, great. One option is to simply copy the header file into your project, not to make sure. No way. Tiny obj loader implementation. Okay, so it's a single header library, I think. So let's actually add that guy. So we're gonna say app.hpp included, let's say here, oopsies, let's include it here, tiny obj loader.h. What? Okay, I hope Copilot playing with me games. Let's go. And then we're gonna go to app cpp. Great. And now what? So before we add app hpp, we could add, what's up with this? Bruh. Define tiny obj loader implementation in the cpp file, and this should build the thing, hopefully. Great. Right. What's next? The data format. Contains single and linear array of vertex data, position, normal, and text chord. Amazing. So we got here the positions, I guess, then the normals. 3 floats per vertex. Great. 2 floats per vertex. Attrib T. Each shape mesh does not contain vertex data but contains array index to attrib T. I guess that's basically indices. Okay. And what else? Robust triangulation. Default is enabled. Great. I already done that in Blender though, but yeah. Great. Okay, example code but deprecated API. The only simple example. Oh well, there is another new objects-oriented API. Great. Okay, so there's a simple example here. Nice. Optimized loader. That's experimental directory. Oh, it's absolute performance. Okay. So this is how you do it basically. You do this, and now you say this: obj reader config path to material files. Great. Okay, let's see. Let's just copy this whole thing, or yeah, let's just go step by step, honestly. So first we gotta create an obj reader parse from file. Obj reader, okay. So where are we gonna do this? Yeah, here. So okay, tiny obj reader, and then what's up if not reader dot parse from file or from string. Of course, from file, asset directory, models cube obj. Good job, GitHub Copilot. Let's go. All right, and let me remove this GLB. We wasted 2 hours from our time. Oh my god. But anyways, delete. Come on. The IDE always plays games with me. Anyways, failed to parse obj file, models cube obj. Great. So that should load the thing. What's next? If not reader.warning.empty. What is this? Reader.warning. Okay, fine. Who cares? If not reader.warning.empty. Great. So now we can get the shapes and the attrib and the materials. Okay, so you loop over all the shapes. I would guess we only have one shape. And loop over the faces. Num face vertices. Loop over vertices in the face. In the face. Okay, access to vertex. Shapes, mesh indices. Bro, this is obj. Why this is crazy? Anyways. Well. Attrib normals. Yeah, can't I just get a whole vertices and indices? Like, is it this hard? Get attrib dot vertices. Well, let me actually debug this and see what's going on there. Okay. Okay, index data reader. Valid attrib. Attrib shapes. There's only one shape, right? Nice. Cube. And the mesh, it contains the indices. There you go. That's what I'm talking about. Amazing. Lovely. Okay. Tiny obj index t. It's of type tiny obj index t. Great. Okay. Tiny obj index t. And then there's num face vertices. What's that? 3, 3, 3, because they're all triangles. Okay. Material IDs, no material. Great. Smoothing group IDs, nope. Tags, nope. Lines, nope. Points, nope. Materials, of course, not. Warnings, not. Error, not. Yeah, pretty simple stuff. Lovely. So yeah, we already have our vector here. std vector tiny obj index t. So you could just give it directly the vector indices. Lovely. The next thing is, where is the actual vertex? Yeah, I would guess I would just give it these. Oh, what? Why? Oh, this is like vector 3, vector 3. Oh, I see. I was like, what? Vertex weights, normals, tick scores, colors. Colors? I didn't include colors. But anyways, there you go. Amazing. So we just have to give it these vertices and these indices. Great. And these are inside of reader attrib vertices and reader shapes mesh 0 first, mesh indices. Okay, great. So we're just hard coding, of course, right now. Later on, of course, we're gonna do something better. We could do better. But yeah, so here's how we're gonna do it. Well, so we don't really need these. We just have to make sure one little thing is that the type would be good enough. So instead of uint, well, yeah, what it uses for the index type, it said here somewhere. Where it's using the index data type, let's see. What about 1632T then? (16-bit). Crazy. I'm sure that I've seen this somewhere. Oh my god. Each shape contains the array. But yeah, anyways, it's easy. What we could do, I guess, is to essentially say tiny obj. Okay. Index t. And then the vertex index, which is integer. Okay, so it's 32T. All right, so let's go ahead and do that. So yeah, oh my god, come on, there you go. So this should be 32T, please. And what is the other one? Is 32T, I guess, or 16? Huh. Yeah, where's my indices? What the? Bro, what? Anyways, I guess I removed them because I'm gonna take them from there. Okay, anyways, so reader dot. Okay, get shapes. So I could get shapes, I could get attribute. Whoa, the API looks so much simpler than the Vulkan API I've been trying to use. Well, I might have to switch Dawn. Theo Paris, welcome to the stream. Yes, it is a bit simpler, and it also handles synchronization for you automatically. But honestly, I didn't have a good experience with it when it comes to debugging. Though I maybe it's just a skill issue. Maybe I don't know how to debug it properly yet. Like, for example, when a shader fails to compile, it just doesn't say anything. But I guess I'm just missing out on something. But yeah. But surely I really love Vulkan debugging. Like the debugging and the documentation is very nice. But anyways, So there we go, mesh indices dot size. That's it. And here, well, just gonna grab this. So auto const indices is equal to these, and then const vertices is equal to get attrib vertices. Lovely. Okay, great. So now what we're gonna do, we're gonna go ahead and we're gonna say decal type of indices value type. No. So let's just say, yeah, let's just say size of uint 32. Well, this is the vertex, yeah, right? Okay, so what is the type of the vertices again? It's realty, tiny obj realty. Well, we could indeed go maybe ahead and say, but anyways, let's not go crazy. Let's say tiny obj and real t, size of that times the vertices dot size, and that's it for that one. Next step would be here size of uint32 t uint32t times indices dot size. And of course here there should be vertices and there should be indices. Okay, let's see. I don't know which order Blender uses, like is it clockwise or anti-clockwise or counterclockwise or what exactly, but I'm gonna disable basically colon and find out. What? Oh my god. Call mode. So what's up now? No idea. Let's see. Did we miss something again? Oh. Oh, no. No. Size of vertex. We still got nothing. This is very weird. Okay, let's see. We got vertices, which contains these. Floats from -1 to 1. From -1 to 1. Is that good for case? Yeah, it's fine, I guess. Right. And then we got the indices here. Oh, hold on a second, what? Oh, okay, I see. So the indices apparently doesn't just contain the normal, like the vertex index, but it also contains the normal index and the text chord index. So yeah, we gotta actually extract them out. So let's go. Let's do it. Oh well, alright. Okay, dot mesh. Is there some helper function for that? No. What a anyways, let's see. So first of all, I'm gonna say, so I don't lose my mind, I'm gonna say this indices.size here just to make sure I don't forget that. Yeah, and the other thing would be yeah, right now let's go basically over all these indices and let's extract them out. Right. So we're gonna loop through these, and here we will just have a const std vector of, well, not that. For now we're just gonna have tiny obj real, is it realty or index, I guess, index t. Ooh, what? Make field vertex index static, what? No idea. Anyways, let's just say 32t. That's the indices. Let's remove that guy there. And this would be like this. But does this even exist? I don't think it does. What? Oh, remove the auto. Yep. And then what I'm doing here, remove the const and the indices reader.get attribute. No, that's not there long. Anyways, so just gonna initialize that, and we're basically gonna say, yeah, something like that, but we're gonna go ahead and say a reader dot get shapes dot mesh dot indices, just like that. Cannot convert U32T, aka and signed into without a conversion operator. Oh, what the? Hold on, what? So this is a vector. So what's up with that? All right, let's go ahead and say indices dot. Oh, I see. Index dot vertex index. And yeah, that should do the trick, I think. Let's hope. And let's see. Well, this is taking longer than I expected. And we've just seen one triangle for whichever reason. Interesting. Well, why? Why? Check the vertices again. All I saw was 1 and -1. Yeah, it's basically floats of the vectors. So yeah, but let me just make sure the data is correct. So here's the vertices. These are basically all vector 3s, I think. Or is it? Oh, okay. Hold on. So it's floats. Okay. Bruh. Well, actually, instead of doing this, let's go back to what we had. And what we could do here, what is the obj file supposed to be? A cube. A cube. This is another level. Yeah, at the very least I should see a quad, right? Could it be an alignment issue? Oh yeah, I remember some alignment issue was brought up here somewhere. Let's see. There you go. Mat.seal, round the buffer size up to the nearest of the multiple of 4. But I don't think that's a problem, honestly. Yeah, I don't think that's the problem. Really no idea. This is ridiculous. All this time I could have made my own OBJ format parser, so that is crazy. Well. Brief primer on glTF meshes. Yeah, I don't think that's the problem. But it would honestly be better if I do, for the vertex buffer, if I do vertex instead, times vertices.size, and then vertices.size divided by 4, like divide by size of float, essentially. I think, isn't it? Oh, there you go, size of 8 bytes. What? What is this vertices? Is it float? Realty, which should be float, right? So yeah, so I'm saying vertices.size divided by size of float, and just to make sure, vertices.size divided by size of float times size of vertex, just so I avoid any alignment issue, I guess. Oh, what the? Are you kidding me? Why this is Vic2? And I should remove these. Huh? Still same problem. Like what the? This is crazy. That makes sense. You know why? Oh. Okay, well, hold on. What I'm doing? Yeah, I lost at this point. That is crazy. Let's go back to what we had before. Size of vertex wouldn't work because we're getting the vertices from... Yeah, let me actually do this right. Let me do this right. Instead of doing this stupid thing, I'm just gonna say a CD vector vertex, okay? Vertices. I'm gonna make my own vector, who cares? Previous definition is here, okay. And then I'm gonna go through all these. And then push it. What's up with this? So let's call this V or something. Oh, okay, I see. The problem with this is that it's floats, but I want vertex. So I guess I could say this. But I don't think if this is something you would do. Well. Actually not this, .vertices.data. Reinterpret cast as vertex. Isn't it? const float. Yeah, fine. Go with const. Well. Super confused now. Hold on a second. Dot vertices. So instead of this, honestly, what I'm gonna do, I'm gonna say int I is equal to 0, or sorry, size t, I 0, I is less than c's dot size, I plus equal to 3. Yes. How many vertices are there? 36. I honestly don't know. There you go. There's like, oh, okay. So there's like 1, 2, 3, 4, 5, 6, 7, 8. 8 vertices times 3. So I guess it would be 23 or 24. 24 probably, yeah, 24. Okay, 8 times 3, 24, right? Position, okay, great. Let's see. So this is gonna be glm vic. Oh. Come on. What? Okay. This is another level. This is another level. Damn. I was going crazy. Well, anyway, let's just do it this way anyway, so I have full control of what's happening, I guess. Or let's just try it now. So reader get attrib vertices. These are the actual data. Okay. Let's remove this for a second. And let's grab this. Now this size in bytes should be this. And these would be floats, not actual vectors. So I'm saying size of float. And finally. 3 hours to make this work, like, bruh. Oh well. So this should be a cube now, but we don't have any transforms yet. But at this point, it sucked the soul out of me. Okay. I guess a skill issue. Now make it spin. All right. Hmm. I wonder if we can like maybe get some OBJ mesh or something like that. Or anyways, never mind. So let's continue with the tutorial, I guess. Tiny OBJ loader. This is what happens when you use libraries and follow guides and copy. You have no idea if you don't use libraries. Yeah, if you don't use libraries, you're gonna stay here forever. App CPP. Let's see. That's wrong. It's C. Oh well. So what we should do now? Let's see. Uniform time. Yeah, can we put a matrix here? Well, before we could do that, we probably want. Don't be afraid. It's not like I never tried not using my libraries before. You have no idea. Oh, anyways. GLM matrix. It should be the, yeah, model. And we got this model matrix, okay. And it seems it's aligned well, so that's nice. But if we don't have this pattern, of course it won't. Nice. Great. Why would you need the library for it? I don't want, like, I'm not interested into doing OBJ stuff now. I don't usually parse files in C++. This is a graphics development, not parsing stuff. So yeah. But anyways, anyway. So we added the uniform now. So how we can add it now? Let's see. So here we got time. Now we got model matrix. And then here we're gonna say mat 4x4, I think. Maybe. Let's see. And there you go, nothing. Let's see. How do you do it in WGSL? Let's find out. How do you do a damn matrix in uniforms? Bruh. Come on, finally. Model matrix. Mat 4x 4f. Yeah, I missed the f. Oh well. Great. Now let me try to basically multiply the matrix by that. So I would guess maybe you say model times vic4f, though we're not passing anything to the model yet, just yet. So let's go ahead and edit that. Where's the uniform? Here we go. So GFW get time, padding nothing, and here we gotta go with identity matrix. Come on, what the? Why there's no identity matrix? Okay, so the one that Copilot have suggested. So this should change literally nothing. What in the world? That's not how it works. Oh, I see. Damn it. Let's see. Uniform. Dot matrix. Dot model. I forgot you are in voice, but I don't hear anything though. Here we go. Right now I unmuted myself, so you can talk now. Hello. There you go. We got the identity matrix now. Nice. Now let's try to do something here. Let's see. Let's just use the global variable for now, just to temporarily. Mat 4x4. And I'm gonna pass this here. And every frame, I'm gonna rotate it. How do you rotate? There you go. But I guess I need the import symbol. Yeah, let me import the whole ext glm thing. Yeah. Yep. Times equal to glm rotate. We'll see what that would do. Though builds a rotation 4x4 matrix created from an axis vector in an axis angle. So the parameters, the input matrix multiplied by this rotation matrix. Huh? Yeah, here they're saying the identity matrix, I see. So I guess basically what I should do actually is this. And the rotation angle expressed in radians, and then the axis. Great. So this, I'm gonna change it to, let's say, 1 radian, or let's say actually pi. Could actually give it a flow, let's say, or something, times GFW. Okay, I need the delta though. I need to, yeah, I see. Okay. And then I could say that last time is equal to GFW get time or something like that. Maybe here or something. And lastly, no, let's do it here. Yeah, we can check it out sometime. Yeah, sure. And here we can say float delta. Well, let's also say now. This is very rough, but it should do the trick, I guess. What is going on here? Oh, I see. That's crazy. Let's remove the sine uniform time thing. Let's see. But no, what's up with this? I have no idea what's happening here. Oh, it could be that it needs to be translated, like maybe it's in, like the camera is inside, maybe? Yeah, it could be the case. So let's actually say, I need to translate it. Do you do the translation last? Right? Let's see. Okay, maybe the wrong direction. Or the wrong order. I'll see. Oh, but we have a problem here. Yeah, because we don't have a camera and stuff. Okay. Yeah. It's weird. GLM translate. Yeah, I'm super tired at this point of this. Bruh. That is crazy. Let's go. Alright, so I think for now I'm just gonna start this. Let's just remove this delta time thing. And let's just leave the matrix alone. And let's say, yeah, let's just play with this a bit, and then we're gonna stop the stream for X4. Okay, GLM translate. But yeah, of course, you don't have any perspective yet. Oh, my bad. My bad. Don't have any perspective yet. So this wouldn't really do anything, wouldn't it? Like whenever you want to initialize in C++, you always use brackets to avoid copies or some weird stuff, and also to avoid narrowing conversions. Otherwise, the equal sign, like the equal operator, isn't like in C. It just assigns like copies memory and stuff. It calls a move. It's called some move function. You can move it, crazy stuff like that. You could use both. It really depends. It's crazy. Like for example, vector. There's two ways to initialize a vector. Let's say. Like if you say vec of 4 like this, then it would it creates a vector of 4 elements. But if you say vec of 4 like this, then it would, I guess, I don't even remember what it do. But basically this and this would do different things. Yeah, that's basically C++. So you have like 5 main stuff. If you override one, you have to override all of them, or you're gonna go crazy. So yeah. Matrix translate resize or scale. Yeah, scale. I guess none of this would actually work without maybe a perspective matrix and all that crazy stuff, right? Currently I only have a model matrix, so yeah, scaling I guess would work without it, kind of, isn't it? Wow. Scale matrix 4 GLM vec. Okay, let's I guess try to add the other matrices too. I have a little bit of breath left. A little bit of patience, I guess, maybe. Let's see. Okay, let's see. So you get the model matrix and the projection matrix, and you could even put a color there if you want to. But yeah, let's just go with these. Time, all of them are matrices of 4. And let's go. Now let's add these here too. GLM mat 4. Projection matrix, view matrix, model matrix. Projection matrix, GLM mat 4x4, view matrix, model matrix. And honestly, I'd rather maybe have them here instead. Let's grab this guy and put it here. And yeah, that's the projection matrix, the view matrix, and the model matrix. Great. Okay. And now we do this. The whole transformation, we combine it in the shader. Oh, my bad. Var or let. I have no idea. Is he using var or let? And there you go, he's added GLM. Finally, let's go. S transpose. It's going through the math manually. But yeah, honestly, let's just say this. Model matrix. Well, U uniform dot projection matrix, view matrix, and model matrix times vec4f 1.0. Great. Now let's basically, I guess we just have to initialize these now. Okay, let's see. So we got the uniform here. This is honestly so bad. Let's just take these and say uniform dot time. And what's going on with this guy? Oopsies. And no need to initialize this because we're going to initialize ourselves. And then uniform dot projection matrix. That's it. Copilot, let's go. Nice. doing the math for me. Well, hopefully the math is correct. Yeah, GLM perspective, radiance, width and height. Let's see what Copilot, is it good at math or not? What's happening here? What? Oh. Yeah, I don't need to write this stuff. Interesting. Because we're writing to every frame. And interestingly, the messages are the same, so that's wrong. I guess. When I resize my window, I just hear your voice go crazy. Gabrielle Burciago, welcome to the stream. Though there is some preemptive thing. Preemptive OS, Linux, kind of real time, I guess it's called, or something like that. I don't. Kernel, exactly. There you go. There's the real-time RT. So in my case, I'm running this Linux. Though there's a new Linux. I guess, maybe. Maybe it could help, I don't know. Not sure. Never really researched about that. So I guess these are the FOV, the field of view, and look at, it's looking at, yeah, I know. I, center, and up. So this is the eye of the camera, like the position, and the center. What? Why it's called center? Position where the camera is looking at. Okay. And position of the camera is here. And then the up vector. Okay, great. I see. And what's up with the perspective? The FOV or the FOV, and the aspect, the near, and the far. Great. And then the model matrix, which is 0. Okay, what if I say 3, 3, so we see the cube, you know, from the corner. Yeah, corner. That would tell me if it really worked or not. There you go. Let's go. Nice. Nice, so it works. Yeah, but once you add color, you're gonna see some problem. We don't have a depth image yet. Gabriel, English is not my first language. It's Moroccan language. It's kind of. Frisco, welcome to the stream. Yeah. Yeah, we don't have a depth buffer yet. The yeah, depth buffer. So once you add color, you're gonna see something interesting. Well, we could try to add some color, I guess. Let's see. Can we do it in Blender? I don't really know how to use Blender that well. Yeah. How can we change the vertices colors in Blender? No idea. Vertex. Nope. Maybe some, let's see, vertex. I know in Houdini you can change the colors specific vertices IDK about Blender. That's particles, physics, constraint, data. There's material. Well, that's gonna go crazy. Let's just kind of like procedurally generate some colors just so we can see something. Let's see how we can do that. So we got the vertex output. We could actually pass anything we want there. And in fact, we're indeed passing the vertex output basically. Passing the whole position, which is nice. So we could use that. Well, we could just use the whole thing, like, yeah. Though, that would probably be a bad idea to use the alpha. Anyways, let's just see what's gonna happen. Not exactly what I expected. I don't know what I would expect anyway. Let's see. Well, no, let's grab the, let's see. Yeah, let's just pass the vertex input, I think. Yeah, let's just pass that. Let's see, vertex output. But yeah, I don't remember even how you do that. Damn. Built-in position. I guess you say location 0. Then you say, I guess, position. And oh yeah, that's true. Oh my god. Let's say pause. Let's see, and then here you're gonna make sure that out pause is in position. And pause is victory. Okay. So now let's see, n dot pause here. There you go. So we need a depth buffer now to fix that. Yeah. Art. Someone gonna make an NFT out of this. Oh my god. Oh well. No, you gotta add a depth buffer first. A depth image kind of thing. And you gotta do a lot of crazy stuff too. Yeah, it's not a lot, but yeah, it's something. No, you do need, like, you need the depth buffer, because like normally if without the depth buffer it would just draw, like the last draw call would basically override anything that is you know, before it. So what happens if you have like some triangle that goes like this, you know? Yeah, overlap like this, where some part of the triangle is like downwards, but the other one is like onwards. So like it's not like just one depth layer, you know. It's like in 2D you just have this. Either it's up, everything is up, or everything is down. You don't have something like this, where some part of the triangle is the one that is shown and the other is the one that is hidden. So you need that depth buffer to actually make that happen, basically. Otherwise you end up with such thing. So yeah, there you go. Let's add a depth buffer real quick. I wanted to do that first so I could see what's going on. Okay, so pipeline state. We gotta change the pipeline state. Depth stencil state equal default. Depth stencil. Okay, let's go to the pipeline description now. Depth stencil. There you go. But what this needs, a const depth stencil state, render pipeline depth stencil. Yeah, let's say as const. Ooh, what's going on here? What? Weird. Depth stencil state. Is it like that? I don't think. Something weird here. Well, there you go. But this should be. What? What have just happened now? This is super weird. Oh, okay. But why it doesn't... Oh, yeah. I see. Because I added it before, but right now it's not there. Okay, hold on. Let me add that little function. And let me see, hold on. Where is it? I got it from the graphics server. Someone told me about it. It's just very interesting. Let's see. Is it Vulkan? Was it, or WebGPU? I think yeah, it was in WebGPU. Okay. There you go. Let's go copy paste, and this would be no discard, and let's go. Okay, so this to simulate C power in C++. So depth stencil. Okay, so now what we could do is as const ptr this, but this is totally wrong. Oh my god. Yeah, like this is a struct. Okay, great. So format plus stencil 8, depth right enabled, depth configured less. Okay, so what's happening now? Stencil front. What is going on here? Let me just see what it's gonna do. Stencil back. We're not going to be using stencil, no? At least not yet. So do we really need to set these stuff? Anyways, let's see the tutorial what it does, what it did. So depth stencil state, set up depth state. Depth compare less, depth right enable true. Okay. Format depth texture format. Stencil read mask. Deactivate stencil altogether. Okay. Oopsies. Stencil read mask. Here, there, it's actually activating it. Interestingly, though, let's not go that far. So let's just remove it. Stencil read mask and stencil write mask. Great. Though, yeah, I don't think we're gonna need this back and front stuff. Yep, no. Probably only depth compare. Because basically you use just 24 bytes, or 24 bytes, 24 bits for the depth, and then you use the remaining 8 from 32 to use it for stencil, basically. Because depth 24 bits is more than enough most of the cases, basically. So yeah, depth right, and stencil could be very useful for, like, for example, when you have, let's say, a boat and some sea, then without a stencil you're gonna have that sea just draws on top, let's say on top of the what is it called, the boat. So what you could do, you could use the stencil so to tell the GPU to not draw that sea where the boat is. Hopefully that makes any sense. I've seen it in some video, go.video. Yeah. Depth right enabled. So that was the example that I actually understood from what is even stencil. I mean, I seen some descriptions before, but it never really clicked. When I heard that example and I've seen it so much, now I understand exactly what it's about, but I don't. Yeah, maybe. So now let's create the depth texture. Okay. And for that, we're gonna need, let's see. By the way, did we, what we have done with, oh, I see. So we're just recreating every time. Okay, fine. Fine. All right. Now let's go to app, and we're gonna add some texture here. WGPU. Honestly, let's just do it maybe after the buffers. I don't know. Doesn't really matter, I guess. Yeah, we're gonna need texture. Depth texture view, exactly. And yeah, don't we need like a texture possibly even? I guess. Not sure though. Texture descriptor, yeah, we do need a texture. So basically the texture is the actual allocation and the view is like just yeah, view to it basically. So depth texture view. Okay, great. So now let's go ahead and see what we could do. Where are we gonna need this though? Hold on. Texture view descriptor. Oh yeah, depth attachment. Interesting. And color attachment. Okay, where we're doing the color attachment stuff, I guess in the render pass. Yeah, we're doing it here, so it doesn't really matter, or does it? depth stencil attachment. You can use raylib if you want. Fragment state descriptor. I would surely use raylib if I want to make a, let's say, a tool or some small game or some small app. Raylib is very good for that. It's like I think the market for simple things, for simple technologies, is very like, it's not very competitive. Like, you only have raylib for creating some powerful, simple apps. Well, raylib does have a compute shader. But it doesn't have, let's say, for example, indirect draw. But you could always just use raylib with OpenGL. But honestly, at that point, why even use raylib? I don't know. Let's see, create texture. Here we're gonna say as const ptr and WGPU texture descriptor. There's no depth here, or what? Depth or array layers? Okay. Width and height, dimension 2D exactly, and then the depth stencil, mid level count, sample count. Great. What's next? Depth texture view, create view. If not, depth texture. And there you go. Is that really it? I don't think. Oh, it does take a descriptor. What the? There you go. Lovely. Great. So I think that's all to actually create the texture. Now for the depth attachment in the render pass. Now, why I would like to use Vulkan? Because of the debugging, it's just super good. The API is super consistent, and you can find great documentation. And the tooling around it is also pretty good. The other thing that I like about using Vulkan, because I want to use some extensions that just makes your life much easier. Like, you can just throw the render passes and the frame buffers out of the window. You don't need those. You could also use bindless, buffer device address and descriptor indexing. So you don't have to constantly juggle between descriptors and render passes and all that stupid stuff that doesn't have anything to do with desktop. So it just would allow you to like create a much nicer architecture of your application, pretty much. So yeah, for example, depth stuff and attachments and crazy stuff like that, you probably don't even need all of these. You just like, here's the depth, work with it, I guess. But yeah, basically I'd like to use modern extensions to make the architecture much nicer, much cleaner without virtual limits. So yeah. Okay, so we got the depth attachment now. Yeah, great. Now we gotta add it to the render pass depth stencil attachment. Great. Okay, let's go ahead and add that. So where we are, let's see, is it right here? Yeah, there you go. So we have color attachments, and we have SCD array, WGPU, depth, stencil attachment. No, what is it called? Hold on. Oopsies. Bruh. Okay, let's see. Come on, what's happening? What's, yeah, what is it? Yeah, I just got it from, what is it called? Kali Linux. It's the slogan, I guess, of Kali Linux. Found it cool. Yeah. Found it cool and put it there. So, yeah, let's see. What is it called? Depth stencil attachment. Well, anyways, let's see. Yeah, that's the first one. Like, that's the first script that I was trying to make, but I couldn't find any tutorial. And then I spent, I guess, 2 weeks or something trying to get it to work, with all those errors and stuff like that. That was super frustrating, but once I've done it, I just published the tutorial, and somehow it ended up the most watched video on my channel. But yeah, when I was just a beginner, like, you can write, like, you can make much better tutorials somehow, because you know exactly what a beginner wants, because you are still a beginner. Yeah. Yeah, pretty much. Like, I don't know. It's like, for example, when you just start, you just make things work, and that's pretty good. But at some point, you start going intermediate programming, and then, like, everything go crazy. Yeah. And then instead of just making it work, then you struggle to even make something, to even start a project. It's another level. Like it's great to be a beginner programmer. It is great to be a senior programmer, but to be an intermediate programmer, oh my god. uh, it's like a bell curve, I guess. Just by doing this. Just by talking, right? Yeah, just enough to get going. Deployed OP. So at first we clear the depth buffer, okay, and then at the end we store the depth buffer, I think so. And then the stencil we clear. Nah, stencil we don't care. And defined, I think. What else? Depth clear value. So what we gonna clear it with? I guess it's gotta be like the farthest point. The farthest depth is the one that you start with, which is basically 1F. Yeah, meaning far. Okay. So clear depth value, I guess. Depth clear value. Yeah. What's happening? There you go. Come on, I hate this. The order. I have no idea who thought this was a good idea. Yeah. Like, even the IDE can do this for me automatically. Like, I have no idea. Anyways, depth read only. So we got the deployed OP, great. Clear, and then store and read only. We could turn off writing to the depth buffer globally here. Read only. Oh, okay, see. Depth read only false. This is super annoying. Okay. Stencil. Oh. Setup mandatory but unused. So you have to clear and store it? So what undefined is for then? Weird. But let's just try undefined and see and find out. Okay. What else? Have we missed something? What? When using the Dawn implementation WebGPU, stencil load OP and stencil store OP must be set to respectively undefined and defined. Let's go. That's what it is. Furthermore, a clear depth attribute of depth stencil attachment must be turned to nan. This doesn't compile in C++. Struct int x y. I can't see. What can you? Let's see. Where did you put it? Which chat exactly? Oh, there you go. There you go. My mind have stopped when I've seen that. What is that? Oh, I see what you're talking about. Yeah, I see. Like, most of the time I don't use it though. But that's very useful in Zig though. At least in Zig I used it a lot. Anyways, furthermore, a clear depth attribute. Though I don't want to deal with errors anymore explicitly. Just throw the damn error at the window, and whenever I want to handle it, I just catch it. So, furthermore, a clear depth attribute of, okay. So we shouldn't actually set it to nan f, okay. Your code is mine. Clear depth. Huh. Depth stencil attachment. Clear depth? I think it means depth clear value. Maybe? That honestly doesn't make any sense to me. Depth stencil attachment clear depth. Super confused. Yeah, I would guess that's basically it, maybe. Must be in the range 0 and 1. Oh. I see. I see. I wonder if that's the same with Dawn. Anyways. Yeah, so basically our vertices goes from -1 to 1, but we need to map it to 0 to 1. So okay, how are we gonna do it? Let's see. In position, we should say XY, right? Then here in the Z we could say in position.z times 0.5 plus 0.5, and hopefully that would work. There's a lot of questions. Hold on a second. I think I've missed something. Yeah, I probably did. Yes, the count. Come on. Stop it. Get some help. Depth, stencil attachment. Oh, it's just one? What? Okay. Alright. Fine. Go ahead and do it. Why is it taking too much time now? Seems to be compiling some Vulkan objects. And yeah, we got nothing. Well, okay. What about if we do here 1.0? Let's see. Still nothing. Let's make sure that these guys are correct. It's great, but I don't know how it's. The problem right now I have with WebGPU is debugging. Oh my god. Like, I don't get any idea what went wrong with my shader. I don't even get the fact that it's like it failed to create the shader. Weird. That's so fun. Probably using tint compiler. So yeah, triangle WGSL. I mean, at runtime it does. I don't know about command line. Probably there is. You just install, I guess, maybe tint compiler command line thing or something like that. And no idea. Let's see how to compile WGSL though. Just pervy. WGSL is terrible. Yeah, but now the debugging. How to compile WGSL to Spurvy. Same result, like what? What about tint here? Tint compiler. Tetris clone. Bruh. Manjaro Arch Linux, so. Okay. Okay. So yeah, no idea what's happening wrong. Doesn't give me any message, nothing, nada. Okay. What? Did Copilot miss this or what? What is this view format stuff? What? What in the world? There's a format, but then a view format's array. Does that even make any stupid sense? Bruh. Okay, depth 24. Plus. Nope. There's a depth slice. Did I miss anything here? No. No idea. The problem right now, I don't know if the shader itself is problematic or is it like when you get an error you just shoot in the dark and just try to find the error. Well, Who remembers? I started a lot of projects. uh, mm, mm, mm. I really don't remember. Very sleepy at this point. Depth stencil attachment. Yeah, I very much wanted for this to work. But damn. Mm-hmm. Oh, I see something. 2D, depth texture format. What are setting the size to though? Interesting. Interesting. Hold on a second. We're setting it to width and height. Oh. Oh. Well, we actually have to recreate the depth texture every time we recreate the swap chain. That's the first thing. So we're gonna do it here. Let's say and it would automatically destroy the other stuff. If not depth texture, texture view. Okay. But what kind of width and height we're using now? Yeah, we're using this. Okay, makes sense. And what kind of format it's using? Texture usage. What? Oh. Oh, it's already half a usage. So that's not the thing. But the other thing that we're actually missing is that somehow you're supposed to give it the view formats. WGPU texture format. Yeah, the same one that you're giving it here. Weird. Okay. So, but the question, yeah, it's using 24 plus. Great. depth right enabled. Depth compare. Ooh, just say plus here. A lot of issues. And then the other thing would be yeah, here the formats. So view formats count equal 1, then view formats const ptr WGPU texture format depth 24 plus. Yeah. And nothing. Yeah. In Morocco, we eat a lot of bread and tea. Tea. Yeah. Well, everywhere there's bad options and good options. Depends on where you go. But like bad in what matter, basically? It's probably the same, I guess. I don't know. Depends. So like there's some people who, like most people actually create their own bread. And then you could also get bread from store. Possibly. Format. Yeah. Nah. It's haram, bro. Let's see. Death only. A no garbage collector. GC. In programming, it's bad for you. Well, pig is also GC. It's also bad for all GCs are bad. Don't use C# and don't eat pork. Let's see. See? Not really. You're forced to. Yeah. Let's see. This is another level. I have no idea what could be wrong here. Debugging experience in WebGPU is just the worst. Like, you're just supposed to just know the errors. That is crazy. Yeah, OpenGL is also bad, but at least OpenGL tells you what happened wrong with your shader. Invalid parameter. Yes. What is it called? OpenGL invalid. Operation, right. What does have to do with Minecraft? How to fix. Like, look at that. I search for OpenGL invalid operation meme, and this is what I got. Minecraft OpenGL error 1282 invalid operation. Bruh, like, the best debugging I got was with Vulkan, hands down. So yeah. Alright, I guess I'm just gonna end it here. I really wish this worked. Well, so yeah, that was it for the stream. And see you later. Though you could still talk with me on Discord. See you, everyone.